Dear students, welcome to the session. Today we are going to discuss decoders. Decoder is a combinational circuit and this decoder circuit basically has n input lines and m output lines. For each n input lines correspondingly there are some m output lines. Okay. Now the thing is, there is a one relation between this n and m input and output lines. If input lines are n, then corresponding output lines are 2 power n. Means for each n inputs will have 2 power n output lines. Okay. So based on this relation, n to 2 power n relation, we are having different types of decoders. That the first one is, for a while, if I assume input as 2, okay, input as 2, then output will be what? 2 power n means 2 square. So 2 cross 4 decoder. N is the input line, 4 is the output line. The relation is what? N cross m. N cross m decoders are always exist, where m value is what? 2 power n. So 2 square is nothing but 4. Similarly, the second type is, if input lines are 3, right? Then outputs are what? 2 cube means 8. So 3 cross 8 decoder. Similarly, if input lines are 4, then this 4 we can write as a 2 power 4, 16. So 4 cross 16 decoder. Similarly, we'll have 5 cross 32 decoder, etc. There are many decoders like this. Okay. Now the thing is, we need to find a logic expression or logic diagram for each decoders. Okay. First I will consider 2 cross 4 decoder here. As we know, 2 cross 4 decoder is a combinational circuit, right? So each combinational circuit we can represent with one block diagram like this. That block represents, the naming of block represents what type of it is. So 2 cross 4 decoder it is, means we'll have 2 inputs. Let's take x and y are the inputs and 4 outputs. I am assuming output as y. So y0, y1, y2, y3 are the outputs. Now we need to find what is the logic diagram which exists in this block. That we need to find. To find the logic diagram, first we need to know logic expression. To get the logic expression, we need to develop truth table, right? So I'm developing truth table here with inputs. Truth table is always gives the relation between input and output values, right? Here the inputs are x and y, and the outputs are y0, y1, y2 and y3, right? See, when we are developing the truth table, the combinations are always depends on the input itself. Means as we are having 2 inputs, the possible combinations in truth table is always 2 square, which is 4, means 2 power n, where n is the input line. As here input lines are 2, so 4 possible combinations are there, which are 0 0 0 1 1 0 1 1. Okay, right. Here, when inputs are 0 0, then directly y0 will be high and the remaining all are zeros. If input is 0 1, then 1 will be high, the remaining all are zeros. If input is 1 0, then y2 is high, the remaining all are zeros. If the input is 1 1, then y3 is high, the remaining all are zeros. It is like a simply conversion. This is binary number. The corresponding decimal is always getting high. See, 0 0 means what? 0 0 of binary is 0 in decimal. So 0 is high. 0 1 means 1. So y1 is high. 1 0 means 2. So y2 is high. 1 1 means 3. So y3 is high. So now we know the expression for each output. Once you know the expression, that once we find the truth table, then we can find the expression. Right? Here we are having 4 outputs which are y0, y1, y2 and y3. See, y0 value is what? X bar, y bar dot 1. Right? No need to write 1 because though it is ANDed with 1, the output value is x bar y bar itself. So y1 means what? In this case only the y1 value is high. So consider this case itself. That is what? X bar and y. y2 means this one, that is x, y bar. y3 is what? X and y. So as I know the logic expression, so I can develop logic diagram. Here to draw the logic diagram, consider the inputs which are x and y, and in that logic expression inputs are complemented and uncomplemented form. So as I am taking input lines directly, so to get the complemented form, give it to one NOT gate x bar and y is given to one NOT gate to get y bar. Now we'll find each expression value. To get y0, which is what? x0, x bar and y bar, give it to one AND, so that you will get y0. y1 means x bar and y, give it to one AND gate to get y1. y2 is what? X, y bar, give it to one AND to get y2. y3 is what? X and y, give it to one AND to get y3. So finally, this logic diagram is basically exists in this block diagram of 2x4 decoder. Okay. Similarly, we can develop 3x8 decoder also. So as decoder is a combinational circuit, we can represent with one block diagram, which is 3x8 decoder. In this 3 means the number of input lines. I am considering it as XYZ. 8 means number of output lines. So I am always representing output as Y. So Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. These are the 8 output lines. Now the thing is, we need to find the logic diagram for this block diagram of 3 cross 8 decoder. Okay. So to get the logic diagram, first we need to develop the truth table for this. So in this, truth table is nothing but it always gives the relation between inputs and output. Here the inputs are X, Y and Z. And outputs are Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. Right? Right. Now, as we know, we are having 3 inputs. In a truth table, there is a one relation. If you have 3 inputs, then possible combinations with that 3 input is 2 cube. Means 8 possible combinations are there. So those combinations are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. See 8 possible combinations. Right? Decoder is what? It will transfer the given binary into an equivalent output, that is like equivalent Y0 means 0, 0, 0 means the corresponding decimal value Y0 will be high. For 0, 0, 1 the corresponding decimal value means Y1 will be high, like that. So 0, 0, 0 means Y0 is high, the corresponding decimal value. The remaining all are zeros. So for 0, 0, 1, Y1 is high, the remaining all are zeros. 0, 1, 0 means 2, so Y2 is high, the remaining all are zeros. 0, 1, 1 means 0, 1, 1 is 3, so Y3 is high, the remaining all are zeros. 1, 0, 0 is 4, so Y4 is high, the remaining all are zeros. 1, 0, 1 is nothing but 5, so output Y5 is only high, the remaining all outputs are zeros. 1, 1, 0 is nothing but 6, so Y6 is high, the remaining all are zeros. 1, 1, 1 means 7, 1, 1 is 7, 7 means Y7 is high, the remaining all are zeros. Right? Now our truth table is over. So once the truth table is over, then we can find the logic expression for each output from this truth table. See, as we are having 8 outputs which are Y0 to Y7, find logic expression for all outputs. See, 1 means what? To get Y0 as high, XYZ must be 0. 0 means consider those values in complemented form. So x bar, y bar and z bar. To get y1 as high, x is a complemented, y complemented and z is uncomplemented form. So x bar, y bar, z. For y2 it is x bar, y, z bar. For y3, which is what? X bar, y, z. For y4, x, y bar, z bar. For y5, what is x, y bar, z. For y6, to get y6 high, the input combination is what? X, y, z bar. And to get y7 high, the combination is x, y, z. With this, the logic expression is over. Now we will develop a logic diagram. To develop the logic diagram, we require basic inputs. Here the inputs are x, y, z, right? And which are sometimes which are in complemented form also. So I am taking complemented input by using NOT gate, y bar, and z is given to one NOT. So I get z bar. Fine. Now we will develop all the outputs one by one. First one is what? Y0, which is x bar, y bar, z bar. Give it to one AND so that you will get y bar. Y1 is what? Y bar, x bar, y bar, z. Give it to one AND to get y1. Y2 is what? X bar, y, z bar. Give it to one AND you will get y2. Y3 is x bar, y, z, y3. Y4 is x, y bar, z bar, y4. Y5 is x, y bar and z. Y5. Y6 is x, y, z bar, which is nothing but y6. To get y7, which is x, y and z, give it to one AND so that you will get y7. This is a logic diagram which exists in that 3 cross 8 block diagram. With this concept, similarly we can develop 4 cross 16 decoder and 5 cross 32 decoder and so on. Now we will solve some numericals on decoders. Here we need to implement full adder using decoders. To implement this, first we need to find output values of full adder. To get the output, just consider truth table for full adder. Right? As we know, full adder is what? It will add 3 binary bits. So I am assuming 3 binary bits are x, y and z, which are inputs. And for adder, outputs are always sum and carry. Okay. Now, as we know, when we are having 3 inputs in a truth table, the possible combinations are 2 cube, means 8 possible combinations are occur, which are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. These are the 8 possible combinations. For all these combinations, we need to find the sum value and carry value. Okay. Here 0, 0, 0 means sum 0, carry 0. Sum is nothing but here x plus y plus z. Okay. So x plus y. 0 plus 0, 0 plus 1. So sum 1, carry 0. 0 plus 1, 1 plus 0. Sum 1, carry 0. 0 plus 1, 1 means x plus y is 1 plus 1. So 1 plus 1 means carry is 1, sum is 0. So 1 plus 0, 1 plus 0, sum 1, carry 0. So here it is sum 0, carry 1, 1 plus 1, carry 1, sum 0, 1 plus 1, sum 1, sum 0, carry 1 and 0 plus 1, 1. Right? Now we are having outputs for sum and carry. Now this write this output values in terms of like min terms. Sigma m of means here sum value is high only these combinations, right? Means sum is high for 0, 0, 1 combination. 0, 0, 1 means what? 1. Next, for 0, 1, 0 means 2. 1, 0, 0, 4. 1, 1, 1, 7. This is a sum min-term representation. Similarly, for carry, output for only these combinations, right? This is what? 0, 1, 1 means 3. 1, 0, 1, 5. 1, 1, 0, 6. 1, 1, 1, 7. Right? Till now we have typed only expressions for sum and carry. Now, these two we need to implement by using decoder. Right? Now, what type of decoder we require? That is the first thing. That is always depends on the number of inputs which we are considering here. As we are considering 3 inputs, so we always consider decoder also with 3 inputs. So 3 means the possible outputs are 8. So consider 3 cross 8 decoder with inputs what? X, Y, Z. Here I am considering X, Y, Z. Right? And output values are Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. This is general block diagram of 3 cross 8. Now, in this, we need to represent some value, means sum is high for all these cases, means either 1 sum is high or 2 or 4 or min-term value of 7 the sum value is high. So consider those values which are 1, 2, 4, 7. For all combination output is high, so give it to 1. OR gate, this is sum expression. Similarly, carry means what? Carry is high for min-term 3, 5, 6 and 7. So give all these values to 1 OR gate. Then you will get the carry output. So in this way, we can design full adder using 3 cross 8 decoder. Okay. Now we'll solve one more example. In this, we need to implement the following 3 functions using decoder. So if you wanted to implement with decoder, first identify what type of decoder is required. Right? That is always depends on the number of inputs which are exist here. Right? As we are having 4 inputs, so consider decoder which is having 4 inputs. So we need to take 4 cross 16 decoder. Here the inputs are A, B, C and D, and we'll have 16 outputs. So I am considering which are Y0, let's take Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7, Y8, Y9, Y10, Y11, Y12, Y13, Y14, Y15. So 16 outputs which are 0 to 15, right? Now we need to represent each function in this decoder. The first function is what? Consider here the outputs high for 3, 6, 7, 10, 13 and 15. Give all these inputs to an OR gate to get F1 function. Means here the output high means for all these outputs 3 or 6 or 7 or 10, 13, 15, the output is high. That is nothing but F1 function. F2 function is what? See, F2 is what? For 1, 9, 12 and 15. I am taking one here. So give it to one OR gate. For all these cases, your F2 is high. Either it may be a 1, 9 or 12 or 15, your F2 is high. So I am using one OR gate here. And third expression is what? 2, I am considering one OR gate to represent F3. So 2, 6, 10, 14 and 15. One more is there, 8. So for all 2, 6, 8, 10, 14 and 15. For all these cases, F3 value is high. So in this way, we can implement any logic function output with decoders. Okay, thank you.